Okay, so The Search for Life Beyond Our Solar System by Simon Rodriguez and Miguel Garcés. Okay, so today in our presentation, we will be discussing astrobiology, habitable planets, exoplanets, and possible candidates for life. So to begin with, our first topic is astrobiology, and astrobiology is the study of life in the universe. The search for life requires, beyond the Earth, requires an understanding of life and the nature of the environment that supports it. So humanity, since the beginning of time, has always looked at the sky and wondered if we are alone or do we have any more species around us. In the late 20th century, as you can see in the picture of the right, we found like a fossil of a microbe in a meteorite. So like this was like the first sign that maybe there is more advanced species outside of Earth. In addition to this, in the 21st century, the new field of astrobiology harnessed the required technological and scientific capability to seriously address the ancient and fundamental question. So to provide this understanding, astrobiology combines the knowledge of many fields, including astronomy, biology, chemistry, geology, atmospheric science, oceanography, and aeronautical engineering. So right now in astrobiology, even though it is a relatively new field, it has a secure and very important future, as it like helps decide space agencies as NASA and the European Space Agency to like what to do next with their missions, like to decide whether or not to search for life in beyond our galaxy, in nearby planets, in everything. Astrobiology helps us decide if we are thinking that it's viable for life to exist or if it is impossible. But in this case, we know that it is highly likely, as the universe is always expanding, that there is another, like we are not alone in the universe. It is, there has to be another species around us. So here is a video from NASA, which like it explains like an overview about astrobiology and like how we are going to search for life like in the following years. This video was released in 2015, I think, and I watched like half of it. Like we don't have time to watch the 43 minutes, but I really recommend it to you as it is very entertaining and it really explains everything you need to know about astrobiology and like the future plans we had in 2015 of exploring different planets and solar systems. Okay, so our second topic is habitable planets. So habitable planets are considered the best to be a candidate of life, which is a planet that has a similar condition as Earth, like, for example, water, an atmosphere, and the right distance, or known as the habitable zone. So the habitable zone is the distance from a star at which liquid water could exist on orbiting planet surfaces. It is also known as the Goldilocks zone, which is where the condition might be just right, not too hot or too cold, and perfect for life. So habitable planets are like where we look for planets that are the most similar to Earth. As Earth has life, we are alive, and we're trying to find planets similar to us so we can prove that we're not alone in the universe. So either finding a single-celled organism like a bacteria or a multicellular organism like us or an animal or something we haven't ever seen before. So it is very important, these habitable planets, because they might provide us with the proof that we're not alone at the universe. Okay, so this 2-minute video will explain further like how it works and the importance of a habitable zone and how every solar system has one.
We inhabit a little blue planet called Earth. Earth is habitable because it had the right conditions and ingredients to enable life as we know it to evolve and flourish. And one of the most important factors in making our blue planet habitable is the wet stuff itself, water. It's kind of extremely important for life. When it comes to the search for habitable we inhabit a little blue, just as important for those worlds. There's a handy concept astronomers use to help them figure out where to look around any given star for exoplanets that just might have the right stuff for life. It's called the habitable zone. It's the distance from a star where a rocky planet with an atmosphere could have liquid water on its surface. In our solar system, the habitable zone extends from around the orbit of Venus to around the orbit of Mars. Earth happens to be nice and comfy in the middle, but it takes more than just a good location. Orbiting in the habitable zone does not guarantee a planet will be habitable. After all, the moon is right here with us, but it's certainly not habitable. Sorry, moon. The location of the habitable zone depends on how big and bright a star is. The nearest star to our sun, Proxima Centauri, has at least one planet in the habitable zone. But because Proxima is much smaller and dimmer than our sun, its habitable zone is way smaller and closer to the star. So every star has a habitable zone, but that doesn't mean there will be planets there. For example, the star known as Kepler 90 is similar to our sun, and it too has 8 planets. But they're all huddled super close to the star, well inside of the habitable zone. But the longer we look, the more likely it becomes that one day we'll find another little blue water-covered planet right in its own comfy habitable zone. And that would be a planet worth a closer look indeed.
Okay, so as you can see, a lot of things vary. The type of star is a great influence of how the habitable zone works. As in our solar system, we have a relatively small star. We can be like 10 AU, like solar units away, and be in the perfect spot, as you can see in the picture. We're not too close or too far away, so we are perfect. But in some other stars that might be bigger, we might be need to be farther away than what we actually are. Okay, so scientists look for a planet to be a candidate for life. For life is that the planet has an atmosphere that is like ours, similar, which contains like oxygen, carbon, nitrogen, and most importantly, water, as water is like the main thing everyone looks for in order to prove that there is life. With water comes life. It is obviously explicit that if a planet has water, it is most likely that it had or has life. We also look for, as mentioned, the habitable zone, which is very important in radiation and to see if the planet will also survive for a long time and the species that may be inside too.
Okay, so for the third topic, we're talking about exoplanets. Okay, so in the next slide, we are talking about what are exoplanets. So exoplanets are an extrasolar planet that orbits a star outside the solar system. Most exoplanets that have been discovered so far are in a small region of our galaxy. Exoplanets are measured by size and masses, and most of them are similar to, for example, Earth and Venus. And that's because they have elements like, for example, they have iron or carbon, also water or ice, and NASA has already discovered some exoplanets with lava in molten seas. For another example, the first exoplanet discovered was in 1990, and after that, scientists have been using different methods, such as the Kepler telescope and also gravitational lensing. The only problem of humanity is that by tracking those planets, it's not possible to travel, as NASA said, in the farthest exoplanet is about 4 light years away, and their radiation exposure is too high. So in this video, they explain like the basic terms of what is an exoplanet.
Awesome. What would be even more awesome if we found another Earth or a bunch of Earths? That's one of the things we're looking for at NASA as we study exoplanets, planets outside our solar system. But maybe searching for a planet similar to our own, where conditions might have led to an entirely unique origin of life, finally telling us that we're not alone in the universe, maybe that's not your thing. That's cool. Maybe you're more interested in just how weird exoplanets can be. We think there are entire worlds covered by deep oceans, water worlds. Not weird enough for you? Okay, how about planets covered entirely in oceans of lava? There are egg-shaped planets, worlds that orbit so close to their stars that they're pulled by gravity into a lopsided shape. And there are planets where conditions might be just right for it to rain things like glass or even rubies and sapphires. There are planets that orbit pairs and even groups of stars. Imagine having 3 or 4 suns in the sky. On the opposite end of the spectrum, there are the loners, rogue planets wandering out in space with no star to call their own. There are even planets that orbit dead stars, stars that exploded long ago and left behind a rapidly spinning core called a pulsar. Some of these pulsar planets could be among the oldest in our galaxy, pushing 13 billion years. Such planets would have witnessed most of the history of the universe. Sadly, nearly all of it without tacos. Now, we think, though we haven't found one yet, that there probably are exoplanets pretty similar to Earth out there. But in the meantime, there are absolutely tons of weird, wondrous worlds in our galaxy. Earth is off.
Okay, so for our last topic, we're going to talk about the possible candidates. So we research for different types of exoplanets that could be habitable, and the most, like, for example, the best candidate planet was the K2-18b, and it is because this exoplanet is the closest and also is the most common to Earth. First, because scientists had seen from the Kepler telescope that there's water, and also they had seen that there's water vapor on the air, and so scientists think that it's possible that there's something, the unknown species that is living there. So this code that we find in the internet, it says this is the only planet outside the solar system that has the correct temperature to support water, has an atmosphere that has water in it, making this planet the best candidate for the ability that we know right now, says Angelus Sierra.
Okay, so that was a presentation about life beyond our solar system. As you can see, we still haven't found a perfect candidate, but a very close candidate, like Miguel showed us. We still don't know if we are truly alone in the universe, but it is quite unlikely that we are, as the universe is always expanding, and it is almost impossible that we are the only species to ever roam the universe. So we hope you liked our presentation, and these are bibliography in MLA format. So yes, thank you.